Control 3. Control Q. All right, welcome to NEC 2020 Code Changes. For everybody's interest, we are going to be talking. I got to look at the 10th. I forgot that the 10th is Good Friday, so I probably will be moving that meeting. I know we had a lot of people registered. I might move that to Monday at the same time. Stay tuned to hear some feedback on that one. But Monday, Tuesday, and Wednesday, Code Changes, NEC 2020. This is going to be a continuation of every day is going to be a building on the previous day. So just keep in tune with that, and let me know your feedback and all that good stuff. All right, everybody's phones have been muted. I believe I've got everybody's phones muted. I have you, so you mute on entry. And don't hit that little microphone button. Please use the chat. You can see the chat button on your screen, and I see people using it already. And so please leverage that chat session to ask questions. And I know that there are a lot of smart people online that will be monitoring chat as well. For those of you on YouTube, please use the live chat. I see people are using the live chat already, so that's a good thing. And we got audio. I've got a good stream, so that takes care of that. I don't want to have to shut anybody off. My name is Thomas Dimitrovich again, and I've been with Eaton for quite some time. I sit on Code Making Panels 2 and Panel 10 for the National Electrical Code. I'm on 70B. I'm on NFPA 73, 78, 1078. I'm on a few UL standards, and I am involved with NEMA, IAEI, and other organizations as well. Anything that you hear on this call today is my opinion, my own opinion. I'm not expressing the opinions of NFPA or any code making panels or anything like that. I'm giving you what I see has changed, what I think is important, what you might need to know. So just want to make sure that you understand I'm not speaking on behalf of anybody. And my YouTube channel is there. If you go out to youtube.com/c/Thomas Dimitrovich, I'm going to be posting materials. I'm going to be creating some videos as well as doing some live things. So all this week I'll be streaming live. I'll probably be streaming next week as well. And depending upon on schedules and whatnot, I'm going to be putting as much out there as I can. I highlight these three organizations as organizations that I belong to that I think have helped me grow in my career. And hopefully those who are watching, if you're not engaged with either the IAEI or NFPA, I would encourage you to join. Those are two really important organizations. They both offer educational materials as well, and they are great from a networking perspective. They offer a lot of venues when we're not fighting a virus globally. We are out talking to people and meeting people. So those are great forums. I'm personally a member of IEEE as an electrical engineer. If you're a mechanical engineer, I know you have your own organizations. I know, contractors and labor will have their own organizations as well. Get involved with those organizations. That is how you build your network. So I highly recommend memberships, and remember to join, and that will keep us strong. So before I go into this, I want to review some of the code change questions that I put out to everybody, and maybe everybody got them, maybe everybody didn't. But if you go to menti.com, that same place where you entered your information to enter your sign in, if you go back out there and put 36, 67, 83, we're going to walk through these questions. I'm going to help you. I'm going to give you my perspective on what I think the right answers are, and we'll take it from there. So I've got the results hidden so right now, and it looks to me like there's 60, 70 some people. So now I see people are out there. We're building it up. So we're getting people to log in. I'm going to, and now I believe that is set at your pace. So once you answer the one question, you can move on to the next one. So everybody can just dial in and start answering these questions. Let's take a look at what the question is. The NEC should always be consulted first before you begin your design. True, false, or I don't know. We have 75 say true, 12 say false, and 2 say I don't know. And I'll tell you where I'm in the ballpark. I'm in the ballpark of the false people. And the reason I say that is we all too often go straight to the code book. And what we're going to talk about in the beginning sessions, which a lot of people ignore, Article 90 of the National Electrical Code. Remember that the NEC says, the NEC tells us that this is not a design guide. This document is I love this statement because everybody forgets about this, especially the design engineers out there. They will go to the code book to see what they need to do. But in 90.1b, and I've got a couple slides on this as well. It says the code contains provisions that are considered necessary for safety. Compliance therewith and proper maintenance result in the installation that is essentially free from hazard, but not necessarily efficient, convenient, or adequate for good service or future expansion for electrical use. So my note on this is that, and the reason I would say the right answer on here is false, is because I think from a design perspective, you should always be looking at what your customer wants and needs are, and then design a system that is designed to meet their wants and needs, and then consult the NEC to make sure that you don't violate any of the NEC requirements. So that's sort of where my head is on that. I don't know that there's a right, wrong, or indifferent, but like I said, this is my opinion, and I'm just looking for who that tweaker is on the phone. We got one person that doesn't have their phone muted, but please mute your phones. So that's sort of that one. All right, so let's move to the next question. The following chapters apply generally to all electrical installations. Now, so I have all 8 chapters listed, and I'm asking which of those chapters, you can select multiple ones, which ones apply generally to all electrical installations. All right, so chapters 1 through 4, and we're going to talk about the Article 90 of the National Electrical Code. 90.3 is your reference for this one. 90.3 tells us that chapters 1 through 4 apply generally to all electrical installations. When you get into chapters 5, 6, and 7, those chapters focus on either special occupancies, special equipment, or special conditions. So 5, 6, and 7 do not apply generally to all electrical installations. They will only apply to the installations where that are under their purview. So for example, Article 555 is where we find marinas. I would go to Article 555 for the requirements around marinas, and then, but I can't forget that chapters 1 through 4 apply even to marinas. Okay, so 90.3 is your reference to understand how the National Electrical Code is organized and how it will operate and function for you from a perspective of what applies to what. But I always get, it's interesting the way the numbers walk out on that one. A lot of people don't understand that. So hopefully those that are in 5, 6, 7, and 8 chapters and the I don't knows just learn something, hopefully. All right, next question. Only those in the electrical industry can make public inputs to change the National Electrical Code. And we know that false is going to be so high. Oh, I love it. So we all understand anybody can make a change to the National Electrical Code. I love to see that answer. All right. All definitions in TE, not the, but TE, NEC are found in Article 100. Ooh, look at that. We got a race going on between true and false. We got 73 in the false, 70 in the true. This is interesting. That's an interesting little split there, isn't it? So here's the thing to remember. Article 100, someone doesn't have their phone muted, but know how to find you. But in any case, Article 100 has all of the definitions that are in the NEC that are used in multiple articles. So if you are in, if you're just relying on Article 100 for the definitions of terms, you really have to look in the dot two of every article. If there is a dot two, like, I don't know, if I just look at, I'm going to flip open to a, I flipped over into 314. Well, boy, that was the wrong one to pick. They didn't follow the style manual. 334, non-metallic sheath cable. 334.2 is titled definitions. So you'll see a note that was an effort in this code cycle, in the 2020 code cycle, to add some text in each of those sections in any of the articles where there are definitions. You'll see text in there that says the definitions in this section shall apply within this article and throughout the code, or they'll just say only within this article. So they've added some clarity to each of these articles that have a dot two that have definitions to help people understand where they're applicable. But you can't just look in Article 100. You also have to look in each of the articles to see if there are any terms used in that article. And then another important thing to know is that if for example, that there's a term used in the National Electrical Code that you cannot find where it's defined, the fallback position is Webster. Merriam-Webster is the official reference for terminology of that which is used in the National Electrical Code when it's not defined in the NEC. But I couch that also with keep an eye on the building code as well. Your other codes could also drive those definitions. So that's an area that if you have, for example, one of the debated topics was crawl space. What's the definition of a crawl space for Article 210, where we have GFCI requirements in a crawl space? We revert back. Many people will revert back to the building code, and same thing with basements, or Merriam-Webster. So that's just a tidbit of information for you that Webster Dictionary or your building codes I would reference. Not sure who's unmuted, but 210.8a is a blank of the NEC. Is it an article, section, first level subdivision, or throw me a bone? Awesome. 84 of you said it's a section. That is exactly right. 210.8 is not an article. You love those people that you can always tell the level of understanding in the NEC when someone will use the terminology incorrectly. They'll say Article 210.8, and if you're involved with the code at all, it sort of cringes on you a little bit. Section 210.8. So if you really want to sound like you really know what you're doing, you say, use the right references when you say Section 210.8, or if you say Section 210.8, first level subdivision A. Oh man, then you really sound like Fred Hartwell or one of the greats in that regard. So remember that is a section. It looks like most of us understand that, but the 70 or 80 so people, hopefully you just learned something. Well, this one shows you the results right off the bat. The maximum current in amperes that a conductor can carry continuously under the conditions of use without exceeding its temperature rating is its rated ampacity, or allowable ampacity. Well, I like this question because I chaired a task group that was sought to clarify this. And what we decided as a task group is that rated ampacity does not belong in the National Electrical Code because it's not rated ampacity. Ampacity is always the amount of current that can be handled based upon its conditions of use. It's not a rating. It's also not an allowable ampacity. It's just pure ampacity. So one of the changes that we made globally, based upon a task group that I chaired, appointed from the correlating committee, we went through the National Electrical Code. We looked at the use of these three terms, and we settled on anywhere in the National Electrical Code where we said rated ampacity, we just called it ampacity. Or if it said allowable ampacity, we just call it ampacity, because ampacity of a conductor is the amount of current that it can carry based upon its condition of use. All right. Taking a circuit breaker from one panel and putting it into another panel is considered reconditioned equipment. I'll stick in that big red title in the middle. It's false. That is called reusing a circuit breaker. That is not reconditioning a circuit breaker. We're always permitted to, if no matter, I don't care what facility I'm in, whether it's in my house on the other side of the wall here, my panel board, if I take a circuit breaker out of commission, I put it on the shelf, and I add another circuit later, I can reuse that breaker. If it was perfectly fine, it was doing its job, and it will continue to do its job. If I decide to take that breaker apart, now I'm into the discussion of, now you're reconditioning it, because you're taking it apart, you're making a change to, because it was not working, and now you're bringing it into a working condition. We're going to talk about reconditioned equipment as a part of this program. So the people, the 154, the guys in the middle, the false, that is the right answer. Those who answered true or not sure, we are here for you, and we are hoping that you understand that now. Adding shunt trip accessories to a multi-case circuit breaker is considered as reconditioning. You could tell I was doing this late last night. Reconditioning that circuit breaker. The answer to that is false. The key thing to remember that when you're working with multi-case circuit breakers, if you're adding accessories and you're doing things per the manufacturer's instructions, that piece of equipment, that device was designed for what you are doing. So when you're following a manufacturer's instructions, and I know sometimes taking the front cover, you'll have to add shunt trip capabilities, you might have to take a portion of the front cover off or the entire front cover off of that circuit breaker. Those do not have a seal on the outsides. Those, you can do that. You can install those shunt trip and other accessory components that go in that, because that is a part of the listing, and that is not considered reconditioning. Power circuit breakers are permitted to be reconditioned. 122 said true, 30 said false, 12 not sure. That is a true statement. Power circuit breakers are permitted, and we do that as an industry a lot. We recondition circuit breakers, power circuit breakers, we recondition motors, we recondition a lot of different pieces of equipment, and the National Electrical Code made some changes, which we're going to go through, to help you understand what can and cannot be reconditioned, and more importantly, when you fall into the definition of being the activity that you're doing on a piece of equipment, when that is considered reconditioning. I think this might be the last one. Multi-case circuit breakers are permitted to be, no, it's not the last one. Multi-case circuit breakers are permitted to be reconditioned. The answer to that is false. We cannot take a multi-case circuit breaker, take it apart, and recondition it. That's now added some clarity in the National Electrical Code in this version of the NEC, and I'll help you again understand that. But multi-case circuit breakers is one of those devices that NEMA and others, and now the NEC, recognize that you really don't want to be taking those things apart. There are some things which we'll talk about that you can do to make sure that a breaker is functioning correctly, and you can do some testing on that. Now, let's take a look at who their favorite hockey team is of everybody. It looks like we've got some Pittsburgh Penguin fans, which is a great thing. Look at this. We have a lot of Pittsburgh Penguin fans, and we have a lot of Steeler fans. Thank you very much. That's awesome. Boy, I knew I loved something about every one of you, and that is it right there. Okay, I'm going to look at the chat sessions here a little bit real quick. Good Friday, James. Okay, blah, blah, blah. There's nothing up there on YouTube. Let's take a look at the chat. What happens when your site is UL approved to make modifications to the breakers? Can't we still not open the breakers and add shunt trips? Yes, you can. Here's the other important thing. If you have a third party reviewing things, even you don't need UL to review adding shunt trips, because you're following the manufacturer's instructions. Now, if you redo a power circuit breaker, you're going to have to get it relisted, and you'll need a third party review of that. So, but in any case, that is you don't have to do the UL stuff to add a shunt trip. A few times I've added shunt trips or aux contacts to multi-case circuit. The manufacturer's instructions said that the field added these factories accessories voided the listing as is possible to cause issues with the tripping. Wow, that's interesting. That was Don Kinnear. I've not seen that. That's maybe it's I'm not familiar with that, Don. If you have some of that material, if you can send me, I'd like to see some of that language. So Don Gannier on WebEx was saying that he has seen where manufacturer instructions said that adding shunt trip or aux contacts to a multi-case circuit breaker in the field voided the listing. That's I've not seen that personally. I'd be surprised if our literature said that, but I wouldn't be surprised if it did and I didn't know about it. So what are the issues when using used circuit breakers? What are issues when using used circuit breakers? The key thing is you don't know the history. So if it's your breaker, you bought it and you've loved it for how many years and you've taken care of it, you know what it's seen or what it hasn't seen. When you're buying a used breaker from someone else, you don't have the Carfax, right? I mean, that's why they came up with Carfax. You think about it. Here's what was happening in the car industry, the automotive industry. You take floods going down in Florida. All of a sudden, there's a huge sale on cars, used cars up in Pittsburgh, Pennsylvania. So we don't want that type of activity going on in the industry, and it's not good for anything, especially circuit breakers and other overcurrent devices that are there to provide protection for personnel and equipment. So you just don't know, David. You don't know the history of that device, so you don't know what it's seen, what it hasn't seen, and how it will perform for you. You can say there's nothing that prohibits selling a used breaker. Nope, other than just natural logic of the history of that. Not all definitions are used in more than one article or in chapter 1. Yes, Don, thank you. That's why I love when Dawn's on the phone. Okay, looks like we're going through all of that. Now I'm going to check my stream. Stream is looking good. We are going into the NEC. Everybody, take a deep breath and get ready. Because the NEC is I consider it a part of there's three key things that we do as an industry. We have installation requirements, and we install electrical products that have that are listed, hopefully listed. And I know inspecting agencies look for that listing mark because that's what helps them feel confident that what you just put in, it wasn't homemade by you. And if it was homemade by you, did you do the right things? So the UL standards and other types of product standards as well work hand in hand with the National Electrical Code. And there's an annex material in the end, in the back of the books, which we'll talk about, that gives you a list of all of the NERDLs and all of the UL standards that and other types of standards that are recognized as being made in combination with the National Electrical Code. But then we have to enforce the National Electrical Code. Now, I didn't throw a slide up here, but I'd throw another, I call it the trilogy, that the National Electrical Code is a part of the trilogy, and the trilogy being the NEC, which is an installation requirement, 70B, which is maintenance of your power distribution system, and 70E is an Edward safe work practicing. Those methods, those three standards and documents work together to help create a reliable and safe power distribution system. So very important to keep an eye on those three documents and help. In some cases, the NEC will drive UL changes, standard changes, and UL standards may change that drive National Electrical Code changes. So they will work in combination with each other. All right. Code making panels, just to give you an idea, code making panels are comprised of individuals that represent different parts of the industry. There's a misconception that only one part of the industry drives code changes, but in actuality, those who sit on a code making panel are approved by the Standards Council, and they look at the qualifications of the applicant. They look at how many people are on a code panel. They don't want to have it too large. You don't want to have it too small. And remember, this is an ANSI process. And they try to maintain a balance of interests. And here's sort of the mix of what you'll see on a code making panel. You'll have manufacturers represented, and I would say that's like your NEMA, National Electrical Manufacturers Association. In some cases, an individual manufacturer may sit on that panel as well. You'll have users. This would be like your petrochem facilities and things of that nature who are users of the code. Installers and maintainers, your NECA contractors, your independent electrical contractors, those who are doing installations. Labor, good example is IBEW, International Brotherhood of Electrical Workers, is a good example of they'll have a seat at that table. Your testing laboratories, your ULs, your Intertechs, your what do you call it? A few others. I can't even think of the names off the top of my head, but I'm going 100 miles an hour. So you'll have those testing organizations, nationally recognized testing labs. Enforcing authority, that's your IAEI, International Association of Electrical Inspectors. They sit on every one of these panels, and they provide valuable input because they have to enforce what the language that we come up with. Insurance companies, you'll see your State Farms, your Allstates, and those type of people sitting on this as well. Your consumers, you'll have a Consumer Product Safety Commission sitting. I know on 210.8, we have Doug Lee from the Consumer Product Safety Commission. Then you have a special expert. Sometimes I would lump like university people, like on, we have Tom Harmon from on panel 2, and I believe he's from University of Texas, down in Texas, Houston, Texas. So you'll, the NFPA manages a balance of this. So not any one of these categories has more influence than another. So it has to be balanced based on the ANSI process. So there are 18 code-making panels, and I say approximately 18 code-making panels because in reality, you got to remember that that code-making panels may come and go. They may combine things, which we're going to show that they actually did combine some things. I believe we went from 19 to 18 this past cycle. About 150 articles, 12 tables, 10 informative annexes. So we have a lot of things to change. And again, we may add new articles or subtract new articles. So I'm going to give you an overview of the day of the process here, and I apologize because I wanted to update this with the latest dates, but I forgot about it. So I'm looking at this slide now, thinking, whoops. So I'm showing you basically a code cycle for the 2023 code cycle. We actually start with public inputs, and the deadlines I think are in August. They moved the dates up a little bit, so. Suffice it to say, come towards fall, you're going to be having a deadline to put public inputs in. We will meet in January of next year to review those public inputs. That's called the first draft meeting. And then we'll publish a first draft around June or July of next year. And so that's the first part of your opportunity to make a public input, which anybody can make a public input. The second draft, you'll have a deadline for public comments because you'll be commenting on the first draft that's published. You can't add any new material in this stage of the game. So if you have some great idea that all of this started to churn in your mind and it would be considered new material, you would not be able to enter it there. If you do, I mean, you could. If you do, the code panel will recognize this as new material and they'll hold it over for next cycle. And then we'll meet. We'll publish the second draft, and probably April timeframe of 2022, and that's your second opportunity to change the code. And then finally, if you still don't like what you're seeing, you have one last chance at the NFPA annual meeting, and that's a fun meeting because anybody who is a member has been a member for 6 months or more. They'll be able to go into that meeting and they'll hold a little voting tool in their hand. And anybody who has a certified amending motion, you'll see the motion put up on the screen and you can hear the arguments for and against the motion. Say the motion is to, I don't know, require all products to have eaten, label only eaten products. And it made it through the first draft and it made it through the second draft. And you're like, this is crazy. I can't just have a code requirement. You can put a certified amended motion in as long as it's certified, and then you can go and you'll hear people argue why that needs to be in the code, and then you get to vote. And if they say it's not in the code, then it stops right there. If they want to add something at that point, whatever they vote to add, if the vote is successful from the floor, that to say add something else that wasn't previously discussed or was discussed and it was rejected by the code panels, it doesn't become a part of the code. It goes back to the code making panel for them to review, and then they get to say yay or nay again, and they could very well say, nope, we still think we did the right thing and we're going to reject that. So, and then after all of that is going on, if you still didn't get what you want, right before the NEC is released for sale, you have one last chance to make an appeal to Standards Council, and that argument typically is really around process. It's not a technical argument whatsoever. You have to demonstrate that the process either wasn't followed or something was amiss or went awry, and you didn't get what you wanted to get in the National Electrical Code. And we did have some appeals this last cycle as well. That's sort of the process in an overview. If you've never seen this before, hopefully it helps you raise awareness that, after the first draft meeting, when we publish that first draft, get out there and take a look at what the changes are so far. This is how we stay on top of what's going on in our industry. And then finally, the next edition is available for the 2023, and then states will start adopting. All right, that gives you a little bit of overview. Now, I want to give you a little case study of how you can change the industry. Your ideas can change the industry. This is an example that was occurred in Article 555, and it was started by a good friend of mine, Joe Fellow, who came to my desk with what you see on the screen now. And in specific, he was speaking to Lucas Ritz and his story. But in any case, every summer we lose more and more people in and around marinas. And Joe's comment to me was, Tom, you're in Codes and Standards. You do stuff with the National Electrical Code. We need to fix this. And he and I sat down and we came up with a plan to put a public input in. His job was to come up with a substantiation. I came up with some language, and then we submitted it to code making panel. I believe it was 19 at the time, because this was back in the day here a few cycles ago. This is what we submitted. We wanted the main overcurrent protective device, which feeds the building or floating structure distribution system, to have GFCI protection for personnel. And we had an allocation in there that individual GFCI protection for personnel fed by that feeder is a suitable alternative to putting it in the main. And you'll notice that it was rejected. Joe Fellow came back to me and he said, it was rejected. What do we do? He was wasn't sure how to handle, what we need to do next. And I told him, I said, I read the first sentence in the panel statement, and I told him there is hope, because the panel came back and said, although the recommendation has merit, that tells me that our idea wasn't far-fetched. Our idea had merit because we had great technical substantiation. We had a huge number of deaths. We leveraged Mike Holt's website, where he was publishing all of these different kids, unfortunately, many kids who were being killed because of electric shock drowning in and around a marina. So I said, they don't like the 4 to 6 milliamps. They said it'll be impractical. I sort of agreed with that as well, because, putting that on the main, all that added leakage current will add up probably kind of quick. So what we went back with was, we said, all right, he and I did some homework. We looked at everybody who made ground fault protection of equipment, and nobody made GFPE that had greater than 100 milliamp of leakage current capabilities. So then we proposed this. We said the main overcurrent protected device, which feeds the floating structure, shall have ground fault protection not exceeding 100 milliamps, and then ground fault protection of each individual branch circuit shall be permitted as a suitable alternative. And it was accepted. 9 people on the panel, 9 voted affirmative. And Joe and I celebrated because we changed the industry at that point. And what we didn't realize was there are a lot of people that did not like this code change for a lot of different reasons. There were some misconceptions, thinking you just had to have 100 milliamp. They didn't really read that it should not exceed 100 milliamps. So 30 milliamps would work, 50 milliamps would work. Anything less than 100 milliamps would work. The NFPA Research Foundation kicked off some studies. They looked at the 100 milliamp and they said, you know what? 100 milliamp, we need to lower that to 30 milliamps on all overcurrent devices feeding the marina, which was then problematic. We had to do a TIA to fix that. We're back to 100 milliamps feeding the marina, 30 milliamps feeding the boat, 4 to 6 milliamps feeding receptacles. We're going to talk about that this week. But we had a task group associated with this, where we expanded Article 555 beyond commercial to non-commercial as well, back where it used to be. And then there was continued NFPA Research Foundation activity, and then NEC 2020 continue that refinement. And I'll tell you right now, I'm chairing a task group that's looking at 555 with Dean Hunter, Donnie Cook from Shelby County, Alabama, and others, very educated. I'm just hosting it and watching them work, and they are continuing this journey to increase safety in and around marinas and other similar areas, agriculture and other bodies of water, etc. So, a simple change. You have an idea, and you recognize good substantiation and that is a challenge for the industry. Good substantiation will go far in this world of the NEC. I'm telling you that right now. It's really important. When you have a good idea, you got to have good substantiation, and you can change the world. So here's how the NEC is laid out. We're going to walk through all of this. We're going to hit Article 90 a little bit because there were some changes in 90. We're going to go through, I don't typically go chapter 1 to chapter 9. I like to talk about topics, and I bounce around a little bit. So for example, I might talk about service entrance equipment. I'll be in 230, 225, 240, and 110. So I'll be hitting all of those in that area when we're talking about service entrance equipment. So I don't make this a, we're now looking at 110.1. Now we're looking at 110.2. Now we're looking at 110.3. I'm going to bounce around a little bit, but it's important to understand how the code is organized to even understand and make sure that we're enforcing it correctly. Now, in this case here, I'm going to take myself out of this picture here. Sorry about that. So chapters, the way this is organized, you have chapters, articles, parts, sections, and the reason this is important to understand is because if you're looking at a section of the code and trying to understand its applicability to your installation, you've got to look at what chapter you're in, what article that you're in to understand the frame of mind. And then in each article, there may be a part. So you may be in part 1, which is general, and that helps you understand that it applies everywhere. Or you may be in part 6, which is medium voltage, and the requirement that you're looking at only applies to medium voltage. So you have to, before you just end with, I read section whatever, and it said this, you got to put it into frame of mind. And I make this mistake all the time as well. Usually the company you keep, if they're good people, they will correct you. And in the code world, you will always be able, you got to have a thick skin. They will correct you. So you have the sections and articles, parts, and etc. So I'm going to just walk through an example section 210. If I say chapter 2, I'm in wiring protection. Article 210 is branch circuits. So when I'm talking Article 210, I'm talking about wiring protection of branch circuits. In part 1 is general provisions, so that applies to all branch circuits. So 210.8 applies to all branch circuits because it's in the general provisions, and I know I'm going to be talking about protection of wiring, etc. And in this case here, 210.8 is the section. I can have informational notes. Informational notes are not enforceable, but they give you additional information. You'll have a first level division and a second level subdivision. Now, I'm pointing to the list items in the first level subdivision. I'm sure guys like Tim Krauscher and crew will probably go, I don't know if I'd call that a second level subdivision because that's really list items. That's true. I think that's true. But in any case, I'm trying to show a little bit of the hierarchy, and I didn't clean this slide up, so apologize for that. You'll have exceptions as well, and then sometimes the exceptions will be specific to one of the list items that are in those first level subdivisions. But that's sort of how it's laid out. And the only message I have for you here is anytime you're looking at a section of the code, understand the frame of mind that that section is in by knowing what part in the article it's in, what article, and what chapter. Okay, so I'm going to hit 90. It's often overlooked by many because you know what? It's like the instructions when you're installing something, right? Where do the instructions go? In the dumpster. So a lot of times we miss Article 90, and I'll just I like to look at 90.1, although it didn't change. And the reason I say that is because it's important to understand to our discussion. One of those questions, it's been around. It's only been around since 1923, And through the years, it's received some changes. And you'll notice that that in the 80s, there was talked about practical safeguarding and adequacy. And in the 2000s, we get into relation to other international standards, and they made minor tweaks. But in the 2014 code, they said the code is not intended as a design specification or an instruction manual for untrained persons. That's an important part of this, is that we don't go to this document as a design guide. We should have our design in place and then refer back to the National Electrical Code to make sure that we don't violate the NEC. It's there for practical safeguarding of persons and property. So what you're going to be seeing today, or maybe today, I think I'm going to hit service entrance stuff today. There's new surge requirements, and yes, the surge requirements that we added are there justified because of life safety products. But in reality, if I am protecting property from hazards arising from the use of electricity, I am still falling into the purpose of the National Electrical Code. And I read this adequacy earlier, that you can make this, but it might not be. You can make it to meet the exact verbiage of the requirements of the code, but it's not necessarily going to be efficient, convenient, or adequate for good service or future. It's a very important thing to remember. Meet your customers' wants and needs first, and then make sure you don't violate the National Electrical Code. And then this is, again, the adequacy. There's references to international codes, which we might get into as we talk forward, but that's all I really wanted to say about that one. We'll take a look that the scope of the code changed in this version. And 90.2, I liken it to the instructions. Where do we go dumpster diving to go get those instructions? Well, 90.2 is the same way. Unfortunately, we don't read 90.2 as enough as we should. But it's really, if you think about it, when you change the scope of this document, that is a huge change. And I'll help you understand why and what changed and why. So this is the way that this section is laid out. We have A, B, and C, what's covered, not covered, and special permission. Now, in the area of what's covered, they added two items. Number one, they added the installation supplying shore power to ships and watercraft in marinas and boatyards, including monitoring of leakage current. Now, that was added because we made, as I said earlier, Article 555 is continuing to change and address the needs to increase safety in our marinas. And what they recognized was, with the groundfall protection, they have boats that will come in to the marina and they will take down the entire marina because they have a lot of leakage current. And that's how Lucas Ritz died. There was a boat that had a lot of leakage current. They plugged into the shore power and they were working on the boats, and Lucas swam into the field and he died because of electric shock. And this, what they did in Article 555, when we get there, we'll cover that. They made a requirement to have a portable leakage device, and they changed the scope of the NEC to ensure that there wasn't any conflict with whether or not they were working in or out of the scope of the NEC. Now, the other thing is they changed and they added, when you export electric power from vehicles to premises wiring, that the scope covers that portion of the electrical vehicles. Now, this is a controversial item that made it to Standards Council on an appeal because they made some changes, and I think that'll be an easy fix. That there's a task group associated with that. I'm not aware of the progress on that task group at this point, but basically they made some GFCI requirements for all receptacles on an electric vehicle, which is sort of the only one they were really going after, was the one receptacle on that vehicle that exports power from the vehicles to the premises wiring. That debate and dialogue is going on probably as we speak with electric vehicle manufacturers and a Standards Council task group. So that adventure, I don't see them changing 6. They may change some of the requirements back in the applicable article for electric vehicles. All right, we got 252 on YouTube. Thank you for all of the YouTube streamers out there. I appreciate you dialing in and playing with us today. Again, where they removed in what was not covered, they removed other than floating buildings and vehicles, because it was sort of redundant that we have articles that address floating buildings and vehicles, and recreation equipment. Why would you say it's not covered when we don't say that for everything else that we have back there? We don't say, you know, um, other than hospitals, other than whatever. So they removed that language from B, cleared that up a little bit. And that's basically the language they removed. So we got to recognize that, again, that's an example of what the environment of a marina provides to electrical distribution equipment. That's a per pedestal. This was on a specific marina. I worked with an electrical inspector. We tested every one of the GFCI receptacles, and I think I recorded over 95% of them were supplying power but did not function correctly because of this environment that they are in. And that's just more reason why we need to really focus on marinas. Marina structures, so we changed, we made some changes to feeders, which we're going to talk about because of the GFPE and GFCI changes that occurred in marinas. We bring more feeders out to these structures, and that violates the National Electrical Code. So we're fixing that. You're going to see how that has been resolved in the 2020 NEC. Again, boats. I mean, these boats are phenomenal. I took that photo myself. Electric vehicle chargers. We already talked about this one. No, I didn't. We talked about that. That's the outlet. But another thing that we changed, which you're going to see as we move forward in 225 for outside feeders. If you recall, you can't bring more than one feeder to a structure, but you can under certain circumstances. But for the most part, for many applications, that would be illegal. And this installation, one of these installations is an example of that, where you have multiple car chargers off of one feeder, where you have to bring two feeders out to it, and that violated the NEC. And we're going to talk about some of the 2020 code changes that helps make what we're doing legal, but yet has an eye on electrical safety so that we don't sacrifice safety in that process. All right, so that's, I already talked about 90.3, 1 through 4 applies generally, and 1 through 7 can modify. Chapter 8 stands on its own. I'm not going to get into that one. Not that I might not come back. So, but all right. So I'm going to hit global changes, and then I'm going to hit service entrance. So for everybody, all 254 on YouTube, and those are on WebEx. Again, the plan this week is I'm going to continue this journey of code changes. Monday, Tuesday, Wednesday. I'm doing circuit breaker basics on Thursday. I'm going to probably move Friday's meeting because that's Good Friday. I just got carried away. I probably will move that to Monday. But in any case, I'm going to continue this. So I got a lot of information, and we're going to take questions online. I'm just looking right now to see what if anything's come in over the YouTube. There, I see them sharing the codes. Thank you. And propose a change. I will need PDHs. All right, let's take a look at WebEx to see what kind of questions have been coming in on WebEx in the chat session. All right, let's go down to the bottom. David, I'm in the same camp with training persons. Not clear in the language. It's not intended as a design guide. Yeah, trained persons. I don't focus so much on the trained persons. I'm thinking from a design guide. That is really important that we recognize. And you'll see it in 220. In Article 220, if you did, I love this. People, I've had this debate with individuals, and if you look at Article 220, 220.12a talks about lighting load for non-dwelling occupancies. There's an informational note. I love this. The unit values of Table 220.12 are based on minimum load conditions and 100% power factor, and may not provide sufficient capacity for the installation contemplated. So we say it right in the code that if you follow this and you do this calculation, it might not be enough capacity. So it's an important thing to remember. Oh, I put a W on W. Fellow, the famous Joe Fellow. I'm looking at the adding shunt trip. Okay, so I think I'm good on that. So let's go to global changes, global domination. Right. Code-wide. When I say global, I mean code-wide changes. There were changes that were made that impacted the entire NEC. There are new articles. Just when you thought you knew the code book, we added new material for you. Not really. But I'm going to tell you the story here. So there's an Article 242 on over voltage protection, but look what they did. They combined Articles 280 and 285. From everything that I've read in 242, I mean, if you're into the over voltage protection and surge, that's what we're talking about, then you're going to want to read 242 and get your eyes on it. But from what I understand, there's not new material in there. They basically consolidated everything into one area. That was the job of a correlating committee task group led by Vincent Saporita from our Eaton Busman division. And so they combined everything into one article, which I think consolidating things like that make it a little bit easier for everybody when you have it all in one place. They created a new article for medium voltage cables. So you're going to see a little bit more in medium voltage. A 2023 task group led by Robert Osborne from UL is looking at medium voltage and the requirements in the National Electrical Code, seeing everywhere where we have medium voltage requirements, they're going to be doing a lot more, and you're going to see a lot more in the 2023. So if you guys are into medium voltage, stay tuned for 2023. There's a lot of activity that there's probably going to be a lot of public inputs in 2023 for the 2023 cycle. They added Type P cable. They added they looked at Article 800 and 805. So there's a new general requirements for communication system. What they did in that chapter, I would liken it to what we have in HAZLOC, or 500 series. We have 500 sort of like your general encompassing, and then they get into specifics. And I know there's a task group looking at power over Ethernet and digital electricity, all of that good stuff. So you'll probably see some love up there in chapter 8, get some changes there as well. All right. Article 280, surge arresters over 1,000 volts. Now, these were where we deleted or relocated. And I just talked about 280 and 285. Those moved to a different article. 328 moved into the other article. And then we had 553, floating buildings. This was a task group, or a working group, actually, that I chaired. It wasn't a task group from the quarterly committee. It was a working group. And I brought out all the industry people, and we looked at Article 555, and they noticed that there was overlap between 555 and 553. And really, when we looked at how small 553 was, we said, you know what, we can consume that into Article 555. So if you're familiar with floating buildings and you're wondering where 553 went, we put that in Article 555. It just streamlined it, and I think it's going to make things a little bit easier. And here's the other important thing. You want requirements to align with each other. You don't want conflict between the two articles or two sections or two chapters. So a lot of the code-wide change stuff is driven by correlating committee task group work. So this work starts, like right now, there's like 5 or 6 task groups going on for the 2023 code cycle. So there's a lot of work being done on the 2023 cycle and looking at different areas. So this work was basically started in just after the 2017 code was introduced. I chaired the somebody mute your phones. I chaired the ampacity task group, which looked at the rated ampacity and allowable ampacity, and we talked about this. So remember, ampacity is based on conditions of use, and we removed all those other terms. Rated ampacity just didn't apply. GFCI task group. So this one, I think I changed. Oh, there it is. GFCI task group. Basically, here's what happened. I'll give you a little story here. 210.8b is other than dwelling units. 210.8b didn't exist in the 80s and early 90s. 210.8b was introduced in mid-90s. I have the exact year in my presentation here, but when we get to GFCIs. But that was before that, we had GFCI requirements back in chapters 5, 6, and 7. So if you had a Marina, your GFCI requirements were in 555. If you had RV parks, and they were all in your specific areas of those sections or articles in the National Electrical Code in chapters 5, 6, and 7. Well, what happened was Code Making Panel 2 in the 17 cycle expanded the GFCI requirements beyond 15 and 20 amps. So then we had a correlation issue between, say, back in RV parks, we said receptacles 15 and 20 amps had to be GFCI protected. But in 210.8b, we said receptacles that are up to, I think it's 50 amps single phase and 100 amps three phase had to be protected. Well, which one do I follow? So there was a correlating committee task group put together, chaired by Jimmy Dollard from Local 98 out in Philly. And they sat down and said, okay, how do we align these so that we're not having this conflict? And they made a bunch of changes, and I'll show you some of those examples once we get into GFCIs. But there have been a lot of changes in that area. Another one, reconditioned equipment. This one actually went up to the Standards Council for an appeal, which failed. And there's a task group associated with this, which is a Standards Council task group. They put a new definition in for reconditioned equipment, and they made some changes in 110, which we will talk about. But this impacted across all platforms. Okay, so then we have a surge task group, which we already talked about. That was chaired by Vince Apparita, and we already know that there was a new article created. I'm not going to dwell on that one. Fault current task group. So this was another one that changed, and I don't think, well, they didn't change the intent. They looked at everywhere we said maximum available fault current. That's maximum available short circuit current. Okay, and I'm going to take short and circuit as 2 words. That's 5 words. They consolidated 5 words into available fault current 3. So they eliminated 2 words, which is a big thing, right? But in any case, they added some clarity, I think, there. They moved the maximum into the definition of available fault current. We're going to talk about that a little bit just to help you understand. But they didn't really change the intent of any place in the National Electrical Code where we referenced the maximum available short circuit current. And then finally, in the definitions, we talked a little bit about this. The problem was there were some definitions in the .2 areas of the National Electrical Code that some people were referencing and using to apply in other areas, other articles. So they have, say that a term was used in Article 555, and it was defined in 555.2, but not in Article 100. But somebody was using that same term and that definition for something over in 690 for PV. That would be, historically, that would cause some confusion, because they would say, well, you can't use that term. You have to go to Merriam-Webster, because that term in 555 only applies to 555. So they clarified this. They said, look, we're going to go to every one of those .2s. We're going to clean this up, and we're going to say, look, tell me if those terms apply only within that article, or tell me if they apply code-wide, and that is what the code panels all did. So you're going to see some new language at the head of every .2 in the National Electrical Code to add clarity. Don't get alarmed from it. Be just adding clarity. All right, so now in this one here, they took, now there's been a debate in the HAZLOC apparently. There are some people that say all the definitions should be in 500, 501, etc. And there are other people that say all of our definitions should be in Article 100. And so they go back and forth. Well, the people who said it should all be in Article 100 sort of won that argument, and they created a new Part 3 in Article 100. That is where you will now find all of your definitions. So all of the classified hazardous location definitions have been moved to Article 100 and placed in Part 3, primarily for ease of use. But if you are a HAZLOC kind of person and you go back here in Article 500 and you say, where did all my definitions go? We put them in that U-Haul and we took them down to Article 100, and that's where you're going to find them. And we tell you what, there were a lot of definitions, so we had to rent a bigger U-Haul. Very important. So that's sort of some of the global changes and what we'll be talking about. And we're at the top of the hour, so that means I've got an hour left with all of you. 277 on 283 on YouTube, and I don't know how many on on this. So let's take a look. Can you explain the difference between a task group and a working group? Oh, yes, Mr. Shapiro. Well, so a task group is appointed by the Core Lane Committee. When I mentioned a working group, I was saying what I did was I myself, I didn't have somebody say, "Hey, Tom, will you chair a task group on this?" I just felt that it was that we needed to get some people together. So I reached out to 244 on WebEx. Yes. So I reached out to a bunch of industry people and said, "Hey, guys, let's get together and let's talk about Article 555." And we cleaned it up last cycle. We cleaned it up again this cycle. There were a lot of definitions in 303. So when I say working group, I'm just isolating that it wasn't an official Core Lane Committee task group, although I kept Mike Johnston and some other Core Lane Committee members very well engaged with what we were doing to make sure everything was copacetic, and we made a lot of good changes. That's sort of Mr. David Shapiro. That's what I was speaking to with that. All right, we are kicking it. We got a lot of people, which is a great thing. I appreciate everybody practicing social network. This is officially the Social Distancing Network Technology Exchange. I think that's what we're going to dub it as. I got to get T-shirts made up and hats, and oh man, we're going to take it global. Let's talk about service entrance. All right. So there were a lot of changes in and around service entrance equipment. I can't express it big enough that if you think about the service entrance equipment is one of those areas in the power distribution system, which is, in my opinion, one of the most dangerous. And the reason I say that is because we can't necessarily shut it off. I can't go to an upstream overcurrent device. I can call my utility, but here's what happens. We all know what happens. You know, I have to schedule that. I get the utility, and it makes it. It's. I think sometimes there's a lot of unjustified work done on service equipment just because they want to avoid the process. But in any case, the service entrance equipment is, and we even have special requirements, right? We have special requirements on the raceway and etc. So in any case, there are a lot of changes in and around service entrance, which I think, in my opinion, again, will do a lot with increasing safety in those venues. All right. So service entrance equipment is one of, again, I said that already, not the only upstream overcurrent devices on the line side of that utility transformer. And I'll tell you, they don't pick that, and Tim Krausher can speak to that too. I think he'll regurgitate that device is not picked to protect the downstream equipment. That primary fuse is there for that transformer, their transformer. And you got to remember that is a medium voltage fuse. From a fuse perspective, the time current characteristic curve is way out there on the right. The chances of that thing opening on an arcing fault downstream in that service entrance equipment is slim to none. It's going to sit there and burn. So in any case, the changes, I think, the changes that were made were very important for electrical safety and driven by some recent code changes that I'll help you understand why the code panels all of a sudden said, "Hey, we have a problem here." I mean, somebody's still unmute. Please remember to mute your phones on the WebEx, guys. Here's what we changed. We changed the 6 disconnect rule. We didn't get rid of the 6 disconnect rule. We just modified the 6 disconnect rule. And so the NEC still permits up to 6 disconnects for service entrance equipment. But what they did in the 2020 cycle was we said we're going to have some requirements around compartmentalization and barriering for the main overcurrent protected device or the overcurrent protected devices in that equipment. So we're going to talk about the 6 disconnect rule in detail. We're going to talk about the line side barrier changes. We expanded the line side barriers. If you remember in the 17 cycle, all service entrance panel boards, switchboards, and switchgear. So in 408.3, I think, or 406.3, I always say 408 when I mean 406, and I say 406 when I mean 408. 406 is your panel boards and or 408 is your panel boards and switchboards, and 406 is your wiring devices receptacle. So in 408.3, I think it was, is where we said we added the word panel boards and it expanded the line side barrier requirement. Well, what they pointed out was, hey, what about a service disconnect that's got service entrance rated? What about the transfer switch? On and on and on. So then they moved it to 230. So we'll be talking about more about that. Short circuit current rating of line side power distribution blocks and similar equipment. We made changes there, and it continued that journey of a change that was made in the 2017 that focused on power distribution blocks, and now they've expanded that to your split bolts and those other types of methods to connect on the line side. There is a new, I still call it the firefighter disconnect, and if you recall during the 17 cycle, if you were engaged with that process, we had a change where the panel 10, I believe it was, accepted firefighter disconnect. Can't remember which panel it was. And they accepted a firefighter disconnect, but it was rejected on the floor of the annual meeting. Remember that, where they all give you those little voting buttons we talked about in the beginning of this program? So this cycle, they cleaned that language up. It passed. It's not called the firefighter disconnect. It's now called the emergency disconnect. We're going to talk about that, and that applies to dwelling units only. You have to have a single disconnect on the outside of a dwelling unit for those first responders. And then there's surge. This surge requirement was not in the new article. This was put in Article 230, and we're going to talk about this. But that for residential, for dwelling units, we have a new requirement to put a surge device in all of those. Thank you, Wendell. CMP4, Wendell Whistler. Thank you very much for that. It was Code Making Panel 4 was the one who put the exterior disconnect for 2017. So we have surge requirements now. That's been expanded, and we're going to talk about that. So now this is an example of the 6, we leverage the 6 disconnect rule. So there are your 6 disconnects. 1, 2, 3, 4, 7, 5. 5, there's 5. 6 is not there. So that's 5 of the 6 disconnects. Tested my Spanish out a little bit. So now you take a look at that piece of equipment. If you take that center, that's a meter center. If I take that off, that centerpiece off, I'm looking at exposed bus. I don't have the ability to put an arc reduction maintenance switch in there. I don't have the ability to say it's barriered. That's exposed, energized conductors that aren't protected by an overcurrent device other than what's on the line side of the utility transformer. So what happened to institute a lot of these changes? You think about what happened in 408.3. It was .3, where we had a barrier requirement for line side disconnects. Kenny Tang, please mute your phone on WebEx. So we had a requirement in 408.3 that basically says all of the line side barriers. But what we had to do for service entrance equipment in that article, we had to say, with an exception, that if you're using the 6 disconnect rule, you don't have to do a line side barrier. And the reason that was because we can't take a panel board or that meter center that's utilizing 6 disconnects and say, I'm going to put a barrier. You're going to require a barrier on it, because it's not possible. So what they did was they put an exception in, and then that caused people to start thinking. That was really the driving factor, because they said, wait a second, we're worried about the electrical worker on this equipment that is at the service entrance, but I'm not going to worry about it if it's using the 6 disconnect rule, which is even less, has more of an issue. So that raised the awareness and to you individuals who made some public inputs to make a change to the 6 disconnect rule, which we're going to talk about. 240.87 and 240.67 also. So they said, look, we're taking this service equipment and we are going to put arc reduction for 1,000 amps and above, but I can have this 1,200 amp panel board with 6 breakers in it, and I'm staring at an energized bus, and there's nothing I can do about it. I can't put an arc reduction switch in there because I have no main overcurrent protective device. I've got a 11016B requirement that tells me I need to label it with a clearing time of all 6 of
The
these
meeting has not yet started.
Oops.
Enter the meeting number followed by pound.
I know I started it. I don't know what that was. But in any case, I'm going to ignore that one. Okay. So we had all these changes in marking requirements, and you're going to have to mark every one of those overcurrent devices, and we're going to talk about 11016. It just didn't add up, and they knew they had to make a change, and that's what they did. They made some changes to the 6 disconnect rule. They made changes to the line side barriers. They made changes to a few of those areas in the NEC, which we're going to hit. We're increasing safety, and we're on that right road, and it will be a good thing when we're done. Right. So this is an example of a service entrance equipment. That's you have the meter, but the main panel board is inside this structure. If I'm a firefighter, if I am a first responder due to a gas leak and I need to kill power to this structure, I can't without entering the structure or opening the fusible, the link up on the pole, or calling the utility. Or I know a lot of firefighters will sit down and say, I've removed meters, and they're going to take that panel open and they're exposing themselves. So this was one of the areas that's going to end up changing. So I'm not going to hit 11016 right now. I'm going to move into 110.26 working space, because this it's not necessarily associated with service entrance requirements, but I liken it there because if you think about it, the service entrance equipment is probably going to be one of the largest pieces of equipment, and the change that was made in 110.26 was around large equipment. So if you think about 110.26 entrance and egress from working space, what they focused on was you have the electrical worker, and if you look in 110.26C, C is titled entrance to and egress from a working space. So they realized that for this large equipment, there's a rule in there that says if your overcurrent device is 1200 amps and above, then you have to have another entrance. They made a change to that because now they're saying, look, it's not whether or not that one overcurrent device is 1200 amps and above. It's really about the amount of energy you have in that room. So it's an addition of the handles of all of those. This is really going to hit your design guys. So from a design engineering perspective, this is commercial and industrial. This is something you're going to have to really pay attention to, especially on your next projects. Even if you've not adopted the 2022 code yet, my advice to design engineers is take your next design where you have equipment 1200 amps and above, or where the handles are all added up to 1200 amps and above. We'll talk about that a little bit more. Make sure you consider this in your design and see how you may have to change your design, or you may have to go back to the architect and say, I need more room. But they modified C, entrance to and egress from, and this is basically the change in large equipment. They're saying the requirement shall apply to either of the following conditions: for equipment rated 1200 amps or more, which is basically what they used to have before, 6 foot wide, over 6 foot wide. But then they added, and remember, this is either of the following conditions. No, it's not both of them. It's either one. If you have a service disconnecting means that are installed in accordance with 23071, where the combined ampere rating is 1200 amps or more and over 6 foot wide, now you're into adding another egress. Because remember, it says for large equipment that contains overcurrent devices, switching devices, or control devices, there shall be one entrance to and egress from. So that's one entrance. But for the working space, at each end of the working space. So in that requirement, so I have one entrance at each end of the working space when I have equipment rated 1200 amps or more, or when the service disconnecting means add up to 1200 amps. So what did we used to do in the past? We would probably take and do a 6 disconnect rule and keep them all below 1200 amps. That kept us out of adding that other door. It kept us out of GFPE. It keeps us out of arc reduction requirements in 24087 and 24067. That's not going to be available anymore, okay? Because now you have to look at the handle ratings and see what they add up to. Now, so again, that's for large equipment, 2 egress, entrance egress, so 2 doors, one at each end of the working space, And that's there for the electrical worker. So this is purely electrical worker related. And then you have to have either of those distances. So I already talked about the 1200 amp and I already talked about this, but here's the other kicker. I think also has a big impact. Open equipment doors cannot impede the entry to and egress from the working space. What does that mean? That means that when you have those doors open, you're going to need to make sure they have enough room. So if you've got to measure your working space from the open door. Now, a diagram says it, a lot more than anything else. But if you have, for example, in this case here, if you have the doors that are shown here, if these doors open further than 90 degrees, okay, then you can leverage that. Leverage that with your AHJ, saying my doors don't open at 90 degrees. There's nothing that says that you have to have the distance based on a 90-degree angle. It just says with the doors open doors. If your doors open all the way, then you're covacevic. Now, another advantage, which it doesn't quite say that, but you might want to talk to your AHJ that if I have removable doors for when I'm doing work, that might be permitted. You have to talk to your AHJ to see if they would agree to that, because the language doesn't say open equipment doors or doors that have been removed. It says open equipment doors shall not impede the entry to or egress from the working space. So again, I'm not an AHJ. I can't say what is good or what is bad. I can just tell you that this will be, I think, a huge impact to a lot of designs. And now I gave this presentation down to an IEEE group down in Texas, down in Austin. My people down in Austin, great people in Texas. What they said was they were going to take this panel. They said, well, if I move it over here to this wall, now my space doesn't add up to the 6 foot. If you put them side by side, they're going to measure the 6 foot. But if I move that room around, then you can't add up the distances. Well, that's a good point, and you may be able to get away with that. I don't know. Again, that is the interpretation of the AHJ. Whatever you're going to do to navigate this new code requirement, you should work closely with the authority having jurisdiction to make sure that whatever you want to do, they agree with, and it's agreed with up front, because you don't want, these are things that you can't fix. I mean, if your room is too small, it's too small, period, right? This is one of those that if you don't take that into consideration ahead of time, don't go out on that limb alone. Go out on that limb talking and communicating with your authority having jurisdiction. But I think the design engineers who work with this equipment can just imagine some of the issues that you may face with the importance of space these days in structures. Right. So that was the 110.26 working space about electrical equipment. That's I think a big change. Now let's take a look at 230.62 service equipment, enclosed or guarded. This is where we get into the booties on the breakers, the barriers. This is all about shock. So again, focused on the electrical worker. Very important that we keep our electrical workers safe. And this requirement, as we all know, with service entrance equipment, we have, you look at this as an example from a residential perspective. All of my conductors, where are they coming down? They're coming down through the top. And remember, these lugs on the line side of that main breaker, I can turn that breaker off. But when you're pulling those wires down, if you're like me, your eyes are staring at those lugs, right? Because you don't want to touch those lugs. Even though you're wearing proper personal protective equipment, and another good reason why gloves may not just be enough. You may need to have something for your elbows and your arms. I know I touched one time a higher voltage. My forearm came in contact with the secondary side conductors of a breaker, and that was not a good thing. So this equipment, you've got to think about all parts of your body, and this requirement is there for the electrical worker and shock. It's not about arc flash, although we can make an argument, some arguments around arc flash and reducing the likelihood of an event, all that other good stuff, but this is about shock. And it continues the journey of what happened in the 2017 code with regard to 408.3. Remember, in 408.3, they added one word, panel boards, to that section of the code, and all of a sudden we had to have service entrance panel boards had to have barriers on that line side, and so that expanded. That was a requirement. That was a requirement that was in the that was just panel boards and switchboards and switchgear. But what happened in this cycle was they said, what about the switches? What about transfer switches? What about a motor control center that's service entrance rated and all of this other equipment? So they've expanded that barrier requirement. For those on the phone who may not know, that service entrance in this case, that main overcurrent protected device is the one up at the top, and all of your branch and feeder devices down and below that. Turning off that breaker does not mean that I have de-energized the line side lugs, because those are energized from the utility, and the only way to turn those off is to call the utility and have them turn that power off for you. These, what you're seeing from most manufacturers, I call them booties, but they are barriers, line side barriers. Put the barriers on, and I would say that, these barriers can be used not just on the service entrance panel boards. They have a lot of value on any downstream panel board where you have a main overcurrent protective device in that panel board. This provides some level of protection. Okay, and that was a residential solution. This is more your commercial solution. You'll see how they tie wrap, and they have a plastic cover. Every manufacturer is going to be a little bit different. So I'm just showing you one manufacturer's solution to this, where they have that line side nice and tightened up so that you can't accidentally come in contact with those conductors that are energized. Right, so the barriers shall be placed in service equipment such that no uninsulated, ungrounded service bus bar or service terminal is exposed to inadvertent contact by persons or maintenance equipment while servicing load terminations. Right, so that again, this is all service equipment. So I don't care. Some people will say, "Well, what about my whatever this is?" If it's listed as service equipment, you are going to have that barrier. This was what they removed. Remember, there was an exception in the 17 cycle that said the requirement of these barriers did not apply to service panel boards with provisions for more than one service disconnect. That is what changed the 6 disconnect rule. That is what changed these barriers. And there was an elevated awareness that we're going to require this barrier when we have a main breaker, but we have this huge hazard of 6 disconnects in a panel board that we're not addressing. But that has been addressed in this cycle. We're going to probably talk about that next. So again, it's reducing the likelihood of coming in contact with exposed energized parts. And I would say, I could argue that you'll probably reduce the chances of an arc flash event too, because if you're barriering things off, you're reducing the likelihood of something happening. You're not making it foolproof, but you have decreased the likelihood of an event on those line lugs. Okay, so that's 230. And now I'm going to open the 6 disconnect rule, but I want to look at the chat session because I see some stuff going on. Booties was not what I had in mind. Okay, I was looking for a metal line side. Okay, so Don Gannier had the idea of a metal line side compartment. Yeah, so here's the difference in the Canadian electrical code. So what Don Gannier is saying, he's saying, look, his thought process was he wanted that whole barrier to the whole top of that panel, like we do in the Canadian code. And that we do have Canadian panel boards that have those. They barrier off the entire top quarter. I'll say quarter. Anything from that main overcurrent device up is all barriered off. And the other thing they do in Canada is they say you cannot bring any other conductors down through that barrier, only the service conductor. Now, that presents a huge problem for here in the US because we always bring all of our conductors down through the joist because our panel boards fit into a joist in between 2 joists or 2 studs, right? And in Canada, they're allowed to put their panel boards on their side. We're not allowed to do that here in the States, right? So that presented a that presented a challenge because in Canada they can put that panel board on its side. So in the U.S. we're this way, and straight up and down. And in Canada I can put it this way, put it sideways, and I can still bring my conductors into the sides of the panel boards, and not have to come through that top compartment. But I can't do that in the United States. So that presented a challenge for us here in the U.S. to do something like they did in Canada. Although the metal barrier is a good idea, Dawn, I agree with you. But we just could not make that happen in the National Electrical Code. So we went with the whole concept of the booties. So in any case, so that's sort of where that came from. The outdoor disconnect does not have to be the service disconnect, just service rated. Yeah, so the outdoor disconnect, which we're going to get to, doesn't have to be a service disconnect. It can just be, it doesn't have to be service entrance rated either. Outdoor disconnect requirement, we'll get it in. Okay, the booties was not what he was thinking about. I am looking at a line up to 33 400 amp disconnects where the width of the individual disconnect is a bit less than 2 foot each. That's 6 foot. The total of the equipment is less than 6 foot, but the total of the outside to outside distance is over. I would go outside to outside distance is what I would do, Dawn. That's, again, the code says the distance is 6 foot. I'm not sure. There looks like there's some discussions going on there. But yeah, so. All right. And I know in the 2023 cycle, I know of a few public inputs that are going to add clarity to that requirement. All right, let's talk about the 6 disconnect rule. The 6 disconnect rule has been in the National Electrical Code for ages. Ages. So what they did in the 2020 cycle was they didn't say that you can't have 6 disconnects. They just said you can't have those 6 disconnects in that same panel board. So what you will no longer see is a panel board with 6 disconnects inside, meeting the 6 disconnect rules, new requirements, and the barrier requirements. You'll probably no longer see that meter center that has 6 disconnects in it, because that meter center has to have, they're going through the UL standard changes. They're having a lot of issues there. But again, right now, because of the words in the code with compartmentalization, there's nothing on the market that will meet that from a meter center perspective. Meter stacks, different story. Meter centers, so you'll probably see mains in front of meter centers to meet that code requirement. It addresses, again, we already talked about we're addressing the issues of 240.67 and 408.3 and how that had influenced these changes and the deletion of that exception. We talked about the fact that 110.16 has all of these labeling requirements. And if I had 6 disconnects, I'd have to have 6 labels of available fault current, 6 sets of clearing time, which absolutely does not help anybody other than the label manufacturers. So that these changes will clear that issue up in 110.16 as well. So there are, and again, 110.16 is the arc flash hazard warning. That's typically the warning that we would have on a piece of equipment. That's the generic warning, but now we have additional requirements in 110.16b that says you have to label it with the nominal system voltage, the available fault current at the service overcurrent protective devices. You'll notice that the word doesn't say the service overcurrent protective device. It says devices, right? And it says devices for a reason, because you could have 6 disconnects there. But that's that. And obviously you could have six separate disconnects as well. But again, that's going to be impacted, because you're not going to have a single panel board with 6 disconnects on it. All right, so that's sort of the labels associated with that. Again, I've been trying to help people understand for 110.16, which is not a 2020 cycle change, but you should be driving the arc flash label as opposed to labeling with an available fault current and a clearing time. I think the intent of 110.16b was really around the 70E table method. But in reality, I don't believe this is really where you want to go because it doesn't provide the electrical worker the information they need to work on that service entrance equipment because they need the clearing time of the upstream overcurrent device, not the devices that are in that panel board. You know, this is where you probably should be going right now as it stands with regard to 11016B because you're following 70E, which is leveraging IEEE 1584 for arc flash calculations and etc. All right. Okay, so 24087, we're going to talk about 24087, so I'm not going to get in there. I'll just basically tell you that 24087 and 24067 influence these changes. And 408.3, which we already talked about. Again, we're on that journey. Let's look at the maximum number of disconnects. So it says each service shall have only one disconnecting means unless the requirements of 230.71b are met. And they separated now A and B, so they created a little bit of an organization, better organization in there. And that 230.71 is, again, it's been restructured. You now have an A and a B, and B is where we made the bulk of the changes in the 2020 cycle. So this says 2 to 6 service disconnects shall be permitted for each service permitted by 230.2 for each set of service entrance conductors permitted by 230.40, those exceptions. 2 to 6 service disconnecting means shall be permitted to consist of a combination of any of the following. So what they did was they gave us a recipe. And again, this is what I refer to as the 6 disconnect rule. They now gave us a recipe of 4 options that we can use. The first option is basically the having separate enclosures. What I would say we'll typically see this when we have 6 fusible disconnects, right? You'll see 6 fusible disconnects or 6 breakers, enclosed breakers. And what's nice about that is each one of those enclosures has an overcurrent device in it. It has a switch in it. You can barrier off the line side. And if you're using the 6 switches or up to 6 switches, then those switches are going to be serving a panel board, which gives you an additional benefit of the overcurrent device giving you lower incident energy at that first panel board or whatever the equipment is. Now, here is another change that says panel boards with a main service disconnecting mean in each panel board enclosure. Now, that tells us that I'm not going to see a panel board anymore that has 6 overcurrent devices inside. That's gone. That's what you used to do. You're going to have to change how you do business because now you're going to need to have a main service disconnecting means, or you might go to option 1. The third option, they lumped switchboards. So this is switchboards. This is saying that each service disconnect has to be in its own vertical section where there are barriers separating each vertical section. So again, this is probably more of a change that's going to impact manufacturers to provide these solutions. But I believe these are readily available to date. And when you put the main service disconnect in each vertical section, you'll be able to barrier off that line side terminal, makes meeting the barrier requirements easier as well. And then finally, service disconnects in switchgear or metering centers, where each disconnect is located in a separate compartment. Now, I don't know why they lumped metering centers in with service disconnects for switchgear. In my opinion, those should be 2 separate items. But I do know that meter centers are presenting a challenge because of all that exposed bus. Some manufacturers think they might have a good solution. It still doesn't meet the National Electrical Code. And that clearing time is, or the clearing time. I was just looking at Jim Williams' clearing time. In any case, that the ability to barrier off and compartmentalize is not able right now in those meter centers. So the standards are trying to address that. And I know they're working on some TIA language to help clarify that one. They added some informational notes to remind us that meter centers are addressed in UL 67. So the standard for panel boards. So, and that's where I'm saying this, the UL 67 STP and task groups have been looking at trying to figure out some language. Nothing's passed yet. So they're still working on that. And I know there's also some energy around technical interim amendment efforts as well. All right, and examples of separate enclosures with a main surface disconnecting means in each enclosure include motor control centers that have a main, fusible disconnects, circuit breakers, enclosures, etc. So again, this is not just this is a big change for the National Electrical Code, and we're changing the 6 disconnect rule, which has been in place for many since the 70s without much change at all. So there's a lot of things being looked at that we've lived with for many years, and they're asking the right questions and taking the right steps to increase electrical safety. So the 6 disconnect rule changed in a manner to increase safety, and it's focused on the electrical worker. It's now with these changes, you're now possible to put barriers on the line side of those terminations. And again, the key thing there is if you are using 6 disconnects in a panel board, you're no longer permitted to do that as part of these changes. Now I'm going to just because we're talking about 6. I'm going to just jump real quick into this discussion point of 225.30, the number of supplies, because I think that's an area that we could probably explore as well. Historically, on these outside feeders, we've only been able to bring one branch circuit or one feeder to a structure. But over the years, and now again, under certain circumstances, you can do that. But in any case, for the most part, in a lot of these areas, we weren't able to bring more than six feeders out. But over the years, we've had these conflicts with like electric vehicle charging equipment, which we talked about a little bit, and marinas. I'm gonna help you understand that again. And we've wanted to bring more than 6 disconnects, or 6 feeders, but we weren't able to do that. Now, the building or other structure served by a branch circuit or feeder. So, in this case here, so what you're seeing now is what you can do is you can now bring multiple feeders out to these locations um, uh, when you meet certain criteria, which we're going to talk about. So you have the ability to bring some, make some changes with regard to pulling more feeders out there. They changed A, special conditions, and they changed 225.30B, common supply equipment. And in A, what they added was down here on the bottom, item 7, which I didn't underline. Sorry about that. They added electric vehicle charging systems listed, labeled, and identified for more than a single branch circuit. So what we're talking about there is that now I can bring, if it's an electric vehicle charging station, then I can bring multiple feeders, because this was historically a challenge. And with the change in the definition of what a structure was, that presented even more of a challenge, because if I look at this electric vehicle pedestal, or if I look at this pedestal, these are structures that are built because a structure is that which is constructed and built. There's an electric vehicle charger that's serving 2 vehicles, and I need to bring 2 feeders out to this. But they say, well, that's a structure. You can't bring more than one, and all these other different things. And even if it is a structure, you have to do some other things because it's a structure. So what we did here was in this code section change, we changed we made this permission in part A specifically to address this, to really add clarity that in the case of these electric vehicle chargers, you can bring more than one feeder out there. Now, another thing that we did was they added docking facilities and piers. Now, if you think about what happened with ground fault protection of equipment in marinas, which we're going to talk about, you have these marinas, which are, every one of those things inside the water, those are all structures. And with the changes in ground fault protection of equipment, there was a desire to bring multiple feeders out to that pier, because they know they have to have ground fault protection of equipment on those feeders going out to the pier, but they wanted to bring they wanted to separate their loads to avoid the accumulation of leakage currents. Well, in doing that, they can't, because that's a structure. So with this change, by specifically putting that language to permit docking facilities and piers in 225.30A, these structures are now permitted to have multiple feeders going out to them. And they would typically take them right down those ramps, and these ramps are movable. and they'll feed panel boards out on those piers to provide additional feeders and whatnot and branch circuits to pedestals and receptacles that are on in those applications. All right, so make sure I have timing here. So where feeder conductors originate, so here's the language that they accepted. Where they originate in the same panel board, switchboard, or other distribution equipment, and each feeder terminates in a single disconnecting means not more than 6 feeders can be permitted. So now we're sort of on that same 6 disconnect rule topic or concept. That's why I put it in here. I'm allowed to have up to 6 feeders. But remember, I have to have a feeder. They all have to start at the same piece of equipment, and they have to end on an overcurrent device. And each disconnecting means has to have a label on what they serve. So this is sort of a diagram I drew. I spent hours working up this diagram. I'm becoming an artist, as you can tell. But the key here is to note that all of those feeders that go out to that separate structure have to originate in the same panel board, switchboard, or other distribution equipment. And when they terminate, they have to terminate in a single disconnecting means. Not more than 6 feeders are permitted. And then you have to label that disconnecting means with what it supplies. So where you're doing that, it has to be marked to indicate the load that is served. It's a relief. I think here's a couple things that'll happen. If you were in any of my classes last week, which I am going to do over again because we had a huge number of people and I had some issues with registration. But in any case, when you take the available fault current at both of these locations is the same. When I change from a single feeder from here to that structure, that feeder is going to be a large conductor, which will have a lower impedance. My fault current at this side will be higher. When I separate into multiple disconnects, multiple feeders, I'll be reducing the wire size, which will decrease it'll decrease the size of the overcurrent protective device in this main equipment. And it will also, because the size of that device is lower, the available fault current and arcing current at these remote locations they'll still be in the instantaneous region of those breakers. So I'll have lower incident energy overall. I should have increased the safety even beyond, I'll meet the needs of the design. And my gut tells me that I probably will address some of the safety concerns. Now, the reference they make to 225.33, again, that's the maximum number of disconnect requirement. So that's, again, your 6 switches, 6 disconnect rule. So, and that's all I have to say about that one. And discard those changes and come back. It's 1:45. What I want to do, I want you guys to go out to Mentimeter again one more time for me. This is going to be a live. Nobody has seen this one. If you go to Mentimeter and type in 932624, I'm not sure if these are going to be automatic or not, but if you go to and type in 932624, I want you to let me know how the Eventbrite experience was, whether it was a poor experience, a great experience. I know I had some people ask me about the login information. I have to fix that a little bit. Just give me some. I know I didn't miss anybody like I did last week. I had some people say they registered, but they didn't get an email. I was using Mentimeter, which is a tool not meant for registration, but Eventbrite is meant for registration. So it looks like it was a good experience. I will continue that one for next week's as well. How about your number one complaint about the registration process? Feel free to type anything in. You had to not like something about it. If you can tell me what that is, that would be great. Nothing, none. All right. So I'm getting the message. No complaints. Easy. Day one was full. Yeah. So what happened was I shut it off. So what I have to do to make sure that everybody gets the information, I have to at some point cut it off, and I accidentally cut it off a little bit too early. There were a bunch of people from AT&T, I think, that were trying to get in. All right, so this is good. Okay, How about I'm watching on, are you watching on YouTube or WebEx? I'm curious to see the mix here. 32 on WebEx, 48. It looks like the YouTubers are down. The YouTubers are like, you know what? They're tubing sleeping. Let's see how many people, I can see how many people we have live streaming right now. Let's take a look at my live stream. 284 on live streaming right now. So that's a good thing. 54. So I got to, okay, we're doing good on WebEx, on YouTube. All right. So that venue seems to be working for everybody. I'm getting a lot of people on both platforms, which is really good. Appreciate that. I think I'm going to move it to the next one now. If you're on a code making panel, what is the code making panel number that you're on? Can you enter that for us? Let's see who we have out there that's on a code making panel. I'm on 2 and 10. We got somebody from 11, CMP4. We got some NAs, nuns, 18. We got an 18 member. Awesome. Right. We have some people out there. That's a good thing. Multiple choice. I don't know what that is. There's not in 1, 2, and 3. There's nothing to put in there. I think that was option 1. All right, you guys are playing along. Oh, right. Well, okay, stop it. We're going to get back to the program. I just wanted to get some feedback. I think that was a question I didn't I didn't fill out. That's what you get when you're doing live. See, going live is a good thing. Okay, so it is 1:48, 10 minutes. I think I can hit, I'm not going to hit 240.87 and 240.67 in 10 minutes. That's going to be its own day. Let's talk 230.67. I can hit that one before we break. You guys are still answering that. Jeez, oh man. Okay, 230, our 230.67 surge protection. We have a new article, over voltage protection. But there are new requirements for dwelling units. But again, that is not in dwelling. That's not in 242. That's actually in 230. All right, 242 surge. Again, it has a focused article now. It does not add new requirements, but consolidates all of those requirements. And again, it brings future attention around performance requirements. So one of the things that's missing, and I don't know where the right home is for it in 242 or 230, we have surge requirements, but we don't really talk about some of the key parameters that you need to have, with regard to performance, right? So I know there are areas. There are people that said, "Well, I just have to have any old surge device. I can buy one that has a higher thresholds and all this other good stuff." So I think it's really important that in the future, and I know there's a lot of smart people on the phone and there's on the WebEx and a lot of smart people on YouTube that maybe you can help try to figure out what is the performance criteria of these devices. But in 230.67, they said all services in supplying dwelling units have to be provided with a surge protected device as an integral part of the service equipment or located immediately adjacent thereto. Let me tell you, the immediately adjacent thereto is critical because that lead length is the shorter the better, the longer the worser, if that's a word. You can take a very expensive surge device, put 6 foot, 12 foot of lead length on it, and it'll do nothing for you. So there's a lot to be learned about the lead length. Right, so all services, the supplying dwelling units shall be provided with a surge protected device. It has to be integral or part of the service equipment or located immediately adjacent thereto. There is an exception. Is required and be if located next to a level dish. So if you do a surge, like say I have a meter center and I have panel boards in everybody's dwelling unit where I'm providing that meter center or meter stack is providing power to a dwelling unit, I could put the surge in every one of those panel boards instead of putting it in the meter center. That's basically what that's telling you. It has to be a type 1 or a type 2, but that still doesn't tell you performance. And then again, it's where it's replaced all of the requirements. So they went so far as to say you have to have, if you're replacing a service, you're going to need you're going to need the equipment with service. All right. There's 4 types. There's type 1, which is permanently connected, intended for installation between the secondary of the service transformer and the line side. And then there's the permanently connected, intended for installation on the load side. And then there's type 3 is the point of utilization. And there's type 4. Remember, we said type 1 and type 2. So it could be on the line side of the service, or it could be on the load side of the service. You're not going to be leveraging a type 3, which is point of utilization, or a type 4, which is what we would typically see inside of industrial control panels and things like that.
So what is a surge protector and how does it work? A surge protection device redirects the transient voltage to ground and away from the connected electrical equipment. The main components inside a surge protector are the metal oxide varistors, or MOVs. These MOVs are essentially electronic switches that conduct when they see a high voltage event. The number and type of MOVs dictates the surge current capacity and life expectancy of your device.
Awesome. I'm glad he was able to make it to this meeting. I wasn't sure if he was going to be able to make it, but he made it. So thank you. That was from our Experience Center up in Pittsburgh. I am probably going to save this annex material, understanding the rating and performance of a surge protected device, for a 1-hour live session. I'm going to probably get somebody from my Surge product line group to help me with that. I know there might be some of them on the phone right now. Expect an email from me. So we'll continue these educational seminars. So again, what the code's telling us, type 1 and type 2. We're going to be up there at the service equipment. Type 3s are what you'll see at point of use. And then type 4s are really, those are the OEM type of application that you'll see installed in those industrial control panels and whatnot. And then I asked Dan Carnevale to come and give us a couple demonstrations on surge before we closed. Dan?
We're going to use a 7,000 volt, 3,000 amp transient to simulate lightning striking near your home or facility. We're going to do this demonstration with a standard incandescent light bulb. Think about if that was your HD TV at home, or if that was the PLC controlling your plant. We're using Eaton Corporation's Power Expert 8000 meter to record these events. The meter uses a 6 megahertz sampling rate, which allows us to capture the waveforms in detail. And you can see from this graph that without surge protection, the voltage went to nearly 5,000 volts.
Now that's huge. He does that same example, and he does it with adding lead length, and he'll demonstrate the amount of let through that you can take that a surge protective device that will perform and show that you'll get these same results if you have too much lead length. So now, Dan, why don't you tell us about what happens if you put surge in the picture?
Now we're going to do the same demonstration with surge protection.
Love it. Thanks, Dan.
With surge protection, the voltage gets clamped to 352 volts, protecting the load.
Now that is phenomenal. You think about what that's doing. It's clamping that from 4,967 down to 352 volts. And what you'll see from an IEEE and a NEMA perspective, what happens with surge, you want to tier your surge devices into a tiered event where you have, what do you call it? You have your surge requirements, or you have your surge protected device at your service entrance equipment. That knocks it down to say 352 volts. And then you can have your surge that a lot of times we'll have surge built into products like smoke detectors, or arc fault circuit interrupters, or arc fault receptacles will have surge built into it. But what you want to do is knock that transient voltage down to a point that they can handle. They're not going to be able to handle that 4,000 volt surge that they can handle a few hundred volts. But if you think about how that transmits down through the power distribution system. So again, we're going to do a deep dive on surge at some point here in the future once I get my surge product line guys engaged and get some knowledgeable people and have more people engaged on those presentations. But in any case, you'll see some of these tiered comments about surge, and I'll tell you from my experience, I was working in Resi for a few years, and I had surge on the house, and I lost. I'll tell you how. You'll understand from the story how long ago it was. But I had my TV, my VCR. I don't even know if there are probably people on the phone that don't even know what a VCR is. A VCR. I had my telephones killed, so I went into my surge product line guy, and we have this what do you call it, warranty system where they cover certain things. And I said, hey, you need to buy me a new TV because I lost my TV and I have our whole house surge on. And so he said, bring the TV in. We brought the TV in. We took it apart, and lo and behold, the surge on the power side worked great, but the surge voltage came in over the cable, and it came over my telephone lines too. So although we have a requirement for surge on the service entrance from a power conductor perspective, we should not forget the fact that we need surge on the data lines that are coming in and your telephone. And I know some people out there on YouTube land and others are going to say, well, he probably didn't have his house bonded correctly. He probably didn't have that inner system bonding jumper that we all know about and love these days. Regardless, I highly advise you putting surge on your data as well. You don't have to just follow the code. Remember, meet your customers' wants and needs, right? And what are the customers' wants and needs? They don't want to lose their TV, phone, and their VCR. I don't even know what VCR. Anybody know what VCR stands for? The Victrola correlating regional something. All right, we are at 159, and what I'm going to do now is I'm going to be a good boy, and I'm going to display our code. I'm going to display our code for the final guys, and as I display that, we're going to take any of the questions that you might have. We'll do that now. So I heard somebody wanted to say something, so unmute yourself and speak. Share your wisdom. Webb's up here. I got hey, Brian Roxon. He is my alternate on Code Making Panel 2. Thanks for joining us, Brian. 210.28 exclusive for SPD 1 through 4. Type 5 is not within the code. Great. 242.12 through 242.18 exclusive for SPDs. Great. That's not in 230. 230 is 1 and 2. Kevin, please I will keep up the live streams. Thank you very much, Kevin. Please subscribe. Remember to subscribe. I'm going to try to do some separate videos as well that aren't live. I personally, I find recording and then posting, some people say that's the way they like to operate. I think I don't have much time in my day, so I try to work off of efficiency. If I'm going to record it, I'm probably going to live stream it. So I may live stream in the evening. I may live stream outside of this 12 to 2. So you'll want to subscribe, and I will try to cover some other areas. Available fault current clearing time is not necessarily the worst case for total arc fault injury. That is true. Now, Jim Williams, I agree with you, and there are a lot of people that agree with you. That's the engineer in you coming out and the engineer in me coming out. But I will tell you, there is validity on the table method. There is validity to the Jim Dollar, Local 98, very good friend of mine, very smart individual. He educated me one day, and he told me, he said, Tom, we were arguing about the table method in 70E that requires you, that it says about the available fault current and clearing time at that fault current. And his argument was people are dying not because they're not wearing the right PPE. People are dying because they're not wearing any PPE, and we need to get our people into personal protective equipment. I agree wholeheartedly, even though, my logic with regard to, arcing currents and clearing times and things like that, the engineer in me wants to do something different. And that's why I always say, we as engineers need to create labeled environments for our electrical worker. And we need to keep our drawings updated. That's our job. That's what we can contribute. We're not standing in front of equipment, but we can make sure that the person who is standing in front of equipment has the right tools to know how to dress. I think it's critical. It's our job. All right, Brian Rock. Tom Brady's hand for his Super Bowl rings. Yeah. Oh, Brian, that hurt. Tom Brady, who? I'm not sure who that is. Is he with the Saints? Can't remember. All right. When will the PDHs be going out? I'm going to expedite that. I'm going to work through that tonight. Here's how I'm going to do PDHs. I've got a ton of people who are who've asked for that. I'm going to create the certificates, and when I create each PDF, they're not going to have your name on them. They're going to have 1, 2, 3, 4, 5, 6 through 200 and whatever. I'm going to have an Excel spreadsheet in that folder I send out to everybody. Download the Excel spreadsheet, find out what number you are, and download that file. I cannot rename that many files and keep and stay sane. All right, so I'm going to look on the WebEx chat. All right, let's take a look. This applies to voltages over 1,000. Eddie privately, I'm not sure what 110.30. One applies to voltage over 110.30. Let's take a look at 110. He was asking about 110.30. So I have somebody, 110.30 is general conductors and equipment used in circuits over 1,000 volts. So that 110.30 and anything in part 3 only applies to applications over 1,000 volts. That is, and I'm not sure what section you were talking about, but if it's in.
Hello, Tom. You there?
Yeah, I'm here. I can hear you.
Hi, this is Eddie.
Hey, Eddie.
Hey, what the question was about was in the new thing that Code Panel 1 put in about the 24 inches of egress space, regardless of whether the doors are open or not. And they didn't put that in the equipment for over 1,000 volts in that part. So obviously the same rule should apply. So I think, in my opinion, that the intent is via 110.30 that that same rule would apply to equipment more than 6 feet in length for over 1,000 volts. Is that what everybody, I guess, on the line is thinking too, or what's your opinion, Tom?
Well, let me look at 110.30 again. Let's find that. So that says conductors and equipment used on circuits over 1,000 volts shall comply with part 1 of this. Yeah, okay. Yeah, so if there is something in part 1 of this article and with 110.30 through 110.41, yes, so that would apply to the over than 1,000 volts as well.
Well, and the way that I got there is because 110.30 sends you back to 110.1, where the scope says this whole article covers the general requirements for the examination and approval, access to and from spaces. So that's how I'm interpreting that same rule would apply to greater than 1,000 volts.
Wow, man, but you know what though? So, I mean, this is 110.26 is right in 1,000 volts nominal or less.
Right.
That's a little bit of a, man, that's a stretch there. I see your journey there, but that is a stretch. That's a good question. Yeah, that's because it's in part 2. It's specific that 110.30 points you to part 1, and it says 110.30 through 110.41, which 110.30 is in part 2, right? So, no, that's all part 3. Part 1 of this article, and with 110.30 through 110.41. So, yeah, I don't think you get into it with. I look forward to your public input, buddy. That's what I would have to. I mean, in the words of Mark Earley, and Jeff Sargent, I look forward to your public input. You're gonna need that. Yeah. But that's how this stuff works, though. I mean, the guys on the code panel, I wouldn't say they've got a lot of workload on their shoulders. It's up to us to keep them up to date. So good. I'm gonna make a note of that myself. And I'll reach out. You know, the originator of this, I think, was Jim Dollar, Local 98. I'm going to bring that up to him too.
Yeah, I guess there's another problem with that too, that I've already put a public input on, and that is, let's say for instance you have your two doors. Let's say you have opposing equipment face to face, hot to hot, condition two, and then if you have a door on one side that opens 90 degrees, a door on the other side opposing faces 90 degrees, and let's say you've got a support post for the building that is in the middle of that 24-inch egress space. So now it's not just a matter of the doors obstructing it, it's the part of the building that's obstructing that 24-inch space too. Whereas before, as long as you had the requisite 5 feet spacing or 6 foot spacing face to face, then you were okay.
Yeah.
But yeah, there's lots of issues that in that C2 110.26 C2 that have to be addressed more than just that one sentence.
All right. Well, yeah, you know what? If you need help on that, if you want to kibitz on it, let me know. I can bring in a few other people who are really good at codees as well. And we could hammer something out that has a good chance of success in the panel.
All right, thank you.
Not a problem. Thank you. Good point. Right. Eric Hurd put out some links. Thank you, Eric. Some of the videos that I show when I get the guys from the Experience Center to come to these things, and I just put it out on the YouTube as well. I think it went out. Yep. There's a videos.eaton.com/experience. We have a whole host of videos that the Experience Center, if you've never been to our Experience Center, it's a treat to help us understand technical things like this. So, all right. So let's see. I'm looking it through. Provide your background. Can you provide your background for reference? So my background, I'm an electrical engineer. My professional engineering license in the state of Pennsylvania, received in the state of confusion, and after which I was in the state of intoxication. I've been with Eaton for 19 years, and before that I worked for Gilbert Commonwealth, which was purchased by Parsons Power. I think it was Parsons, consulting architectural engineering firm. I did a lot of work in industrial, commercial, nuclear. I was at Crystal River Unit 3. I wrote some short circuit and voltage drop studies that the NRC or the various nuclear utilities use for calculating single phase voltage drop and single phase short circuit for their critical stuff. And so, again, my background is a power systems engineer. So I graduated from Gannon University with a focus in power. So I had my symmetrical components, complex variables, all those good things. And I have a love for power engineering. You know, I used to be really good at digital, and I did a short circuit and coordination study for power systems development in Canton, Ohio. Those guys were awesome. The CEO hired me and told me make up a project, and he gave me a Union Carbide plant down in West Virginia. And I did a walk down. He gave me the Beeman handbook, the Westinghouse transmission and distribution book, the Blackburn relaying book, and a few others. And I did a short circuit study by hand, calculated all of the impedance diagram. I did a coordination study by hand. I built my own light table. And then at the end of the summer, he gives me SKM systems analysis and says, I don't know what this stuff is. And I did everything I did in that summer. I did it in like a week with some help from Lon Lindell out at SKM. And so I fell in love with power engineering back then, and my experience in that internship got me my first job with Gilbert Commonwealth. And then I was stationed down in Florida. I was stationed down in Tennessee and a few other places, and I started to work with Eaton in 1995. I've been through all different types of product lines, and I had a lot of fun. And now I'm stuck at home and doing this good stuff. And so I sit on panel 2, 10, and 70B, 78, 1078, and a few others. Yeah, Brian, and then the state of denial. So in any case, so that's sort of my background, and I've been in a lot of different product lines within Eaton. I'm now working out of the Bussman division, And what I love about the busman guys, the fuse guys, is they have a really hardcore sense of understanding power systems, because the value of the fuse comes out when you calculate your fault currents and do calculate your selective coordination and do your short circuit current ratings and all that good stuff. So that's sort of my background. Thanks for asking, whoever that was. How do we get this presentation? So I am going to have this, it's being streamed on YouTube. Go to www.youtube.com/C as in Charlie, Thomas Dimitrovich, or you can go to YouTube and just search for my name, Thomas Dimitrovich. You'll find it. I have my last week's programs, which was Monday was short circuit calculations, Tuesday was selective coordination, Wednesday was GFCIs, Thursday was AFCIs, and Friday was safe work practices. I've had a couple requests to do those over again. I will probably schedule that in a later date and do those over again. So I did those last week and got the learning curve on how to stream and all that good stuff. But I'm going to, again, Monday, Tuesday, Wednesday. I'm going to probably reschedule Friday for Good Friday. I'm just not clobber. And I'm right at noon. I mean, that's when we should all be. Anyway, that's when some people are wanting to have some good silent time. So in any case, I'll probably put that on Monday. I can see YouTube. So here's the link for the video. Thank you very much. Check out the Experience Center videos. We still have 192 on YouTube. Thank you for hanging in there. The 6 disconnect rule will also apply to section 590.4a T-pole installations. These are all posted on YouTube. Yeah, so when this gets done, when I get done with this, I'm going to edit out the beginning because I don't want these Mentimeter codes. And here's what I'm going to do. Hopefully everybody got their Mentimeter codes. Well, I'll probably edit all of this out anyway. I can blur it, I think. This question was, we're going at 590.4. Just going to take a look at 590. The question was around 590.4. 590 is temporary installations. Ooh. 6 disconnect rule will also apply to section 590.4a. Yeah. I would agree with that. Services shall be installed in conformance with parts 1 through 8 of art. Yeah, so that is true. Yeah, you've got to think about the 6 disconnect rule in 590 for temporary installations. We're going to talk about these temporary installations, but I would also point you guys, since we have a 590 person here, I think it's in temporary installations. Look at 590 dot, and we're going to talk about it, but you can 590.6, the assured equipment grounding conductor program. Where's it at? There wasn't 590.6. There was another change in 590 for temporary. For the life of me, I can't find it. There it is. No, that's not. But anyway, maybe I'm thinking, yeah. It's in my program, but wherever it's at, I'm not sure where it's at. It might be in 590.6 ground fault, but anyway, no, there it is. 590.8. It was on the little short page on 70.507. 590.8 overcurrent protected devices, where reused and service overcurrent protected devices. I'm not going to read it to you now. That is something you can do online by yourself. So check it out. But yes, thank you, Chris. 590.4a. We still have 177 people on YouTube. Timothy, it probably feed or disconnect. So booties, I think we hit everything there. Jim Williams is on his 3rd week of shelter in place. Remember, Jim, to eat and drink frequently, please, between these classes. And awesome, beautiful streaming operas. There you go. Right, so I don't see anything on YouTube. Kevin, thanks for everybody dialing in on YouTube and hanging out in there. I didn't see any questions about the Mentimeter and putting the final little quiz together. And awesome. So for the people on YouTube, I'm going to fade to an outro. I'm going to cue that up. And I appreciate everybody on YouTube dialing in, and everybody on WebEx dialing in. We're going to see you tomorrow again. Remember, if you didn't register for tomorrow, get out there to Eventbrite, and I will make sure that I'm going to extend the registration. We had great response to this, and I'm looking forward, hopefully, to people tomorrow as well. So we'll continue our discussion and continue through this slide deck. Thank you, and I'm going to sign off on both venues here. I'm going to sign off on YouTube first. The guys on YouTube, thanks for joining in, and I will see you again tomorrow. Outro. Yeah, I'm getting the event in.